Hello and welcome to another Ginger Mathematician video. So today we're going to go through the Specimen Paper 2 for 2025, and this is Specimen Paper 2A. Now I've had a few requests for this kind of video, so let's go through question by question and make sure we're happy with this non-calculator kind of paper. Again, no calculators being used in this paper. Right, let's get started. So we've got work out 0.01 all squared. Remember, when you're squaring something, this is the same as timesing by itself. So the way I like to do this with non-calculator methods is, of course, 1 times 1 is equal to 1. But then let's have a look at how many decimal places we have. So we've got 2 here and 2 here. So there should be 4 in the answer. So 2 here, 2 here. So when I write my answer, 0, 0, 0, 1, I'm making sure I've got 4 decimal places in the answer. So 0.0001. Nice little trick to know. Now we've got some significant figures, so correct to 4 significant figures. So the way that we do this is we go first significant figure, second significant figure, third significant figure, and then we have the fourth significant figure. So we want to draw a line between this 9 and a 9. Now it's a slightly tricky question because remember the 9 rounds it up to 10. So what we're going to get here is 57.40. So we're bringing the 39 then to 40. And it's important, of course, to have that 0 there as well. Okay, notice they've got correct answer only. That's what CAO stands for. So you have to have the 0 there, otherwise you won't get the mark. On to question 3. So Amy changes 250 euros into dollars, and we have the exchange rate. The way I like to do this is we've got 1 euro is $1.10, and we want 250 euros. So what do we do from 1 to 250? Well, we multiply by 250, and we do the same on both sides. So we need to do the calculation of $1.10 times 250. Easiest way to work with decimals is just to times the numbers together normally. So we do 11 times 25. Lots of different methods for long multiplication. I'm going to do it old school here. So we have 1 times 5, that's equal to 5. 1 times 5 is here, also 5. Then for the 2 here, we add the 0. 1 times 2 is 2. 1 times 2 is 2. If we add those together, we get 270. I can write this in. Oh no, so close. Okay, let me write it above here. If we add those together, we then get 275. Again, when we think about the multiplying that we do here, what kind of makes sense? Actually, $275 does make sense here. Notice we've got 1.1, so 1 decimal, but we have a 0 here, so they kind of cancel each other out. But again, a quick common sense check says $275, 250 euros. That makes sense. If it was $2,750, that doesn't make so much sense in the context of the question. So you can have a look at the answers there. Again, these are all 1 markers, so there's no method marks here. Okay, question 4. So we've got 2 triangles, ABD and ADC. BDC is a straight line, that's important. AB is equal to AC, so these 2 lines are the same. And we've got these 2 angles, 61 degrees and 81 degrees. And we want to find angle DAC. The hardest part usually of these questions is identifying the angle. Notice the middle letter that tells us where the angle is. So we have DAC, so it's going to be this angle that we're looking for here. Okay, so we've got an isosceles triangle. So if this is 61 degrees, then this angle over here also has to be 61 degrees. So I have an isosceles triangle, key word for this question, isosceles. And now we want to work out the missing angle here. So remember, all angles add up to 180 in a triangle. So 81 plus 61 plus this angle DAC is equal to 180. And again, we can just simplify this down. So 81 plus 61, that's equal to 142. And then we want to get the angle on its own. So what's the opposite of adding 142? Well, we minus 142 from both sides. This cancels, giving us, well, DAC, so our angle DAC. And 180 minus 142. Again, if you're not confident with mental methods, we can always use normal subtraction here. So we take 1 from here, borrow it, and we get 8 3, and this is 0, so we get 38. So you can do the mental maths here, but then you can also check with your normal subtracting ability here. So we again get 38 degrees for our 2 marks. Again, the mark scheme you can see here, and you get a method mark for this calculation here. So even if this went wrong, again, at least I've done this calculation, 180 minus 142. This would be where the method mark is. Okay, on to question 5. So, okay, you have to be very careful with these convert questions. Here we've got 0.17 square meters is equal, what is it in square centimeters? Now remember that we have 100 centimeters is equal to 1 meter. However, if we're working with square units, so square centimeters and square meters, then we have to make sure that we square the unit here. So this is going to be 100 squared, so 100 times 100, and that's equal to 10,000, so 4 zeros. So again, you can either learn this fact off by heart, some teachers will recommend this, or just show you that, okay, when looking at length units and area units, we have to be very careful. So if I want to convert 0.17 square meters into square centimeters, I'm going to be timesing by 10,000. So this is the biggest mistake that's made in these questions, most times by 100, but not 10,000. Now, if I'm timesing by 10,000, so we've got 4 zeros here, so we go 1, 2, 3, 4, so my new decimal point, put in zeros in the gaps, and then we get our answer of 1,700 square centimeters. Notice you just get 1 for the answer, there is no method marks here. Now, next question, so question 6, the mass of a solid metal cuboid is 4 kilos, volume of the cuboid is 600 square centimeters, and what the density, which they even give you the formula for, that's nice of them, and giving your answer in grams per cubic centimeters. Now, they put this in bold, and usually there's a reason they put this in bold. Notice we have square centimeters here, this is all good, but we don't have this in grams, we have this in kilograms. So the mass here is 4 kilos, but that's the same as 4,000 grams. Remember your conversions, very important for this non-calculated paper. 1 kilo is equal to 1,000 grams. So make sure you keep that in mind. Now we use the formula for density. So we have density is equal to mass, which is the 4,000, divided by what we have here. So the volume of the cuboid. Again, the units are absolutely fine here. So 600. And we need to simplify this down. So we have 2 zeros here, so we can cancel through. So we get 40 over 6. Again, we can simplify that by dividing by 2. That gives us 20 over 3. Again, we can either write it as 20 over 3, or we can write it as a mixed number. So how many 3's go into 20? That's 6. Remainder 2, so we get 6 2/3. So you can either write it, like it says in the mark scheme, 6 2/3. I generally just leave it as an improper fraction, 20 over 3, which is fine. Notice we have here or equivalent. This is what the OE means here. So you're getting a lesson here also in the mark scheme and how it works. So as long as you've got something that's the same as this, so say you wrote 6.6 recurring, some people prefer this, or what I wrote, 20 over 3, you'd get all 2 marks for this question. Okay, on to some vectors here. So question 7, how do I know I've got vectors? Well, I've got this bold text and these big brackets. So again, I know this is a vectors question. If you need more practice on this, I've done 2 videos on all things vectors and also a new Udemy course as well, which you can check out in the description and above. So first of all, we need to find u minus 2v. So our u here is 3 minus 2, and then we do minus 2 lots of v. So we times this by 2. So minus 12 times 2 is minus 24. 5 times 2 is 10. And then we just remember our negative number rules. So we have 3 minus minus 24. And then we have minus 2 minus 10. So 2 minuses make a plus when they're next to each other. So let's write this in. 3 plus 24, that's equal to 27. And be careful with negative numbers here. You have no calculator to check this with. Minus 2 minus 10 is equal to minus 12. Imagine it's minus 2 degrees, and it gets 10 degrees colder, then it's going to be even more negative. So we have to be careful with this and get 27 and minus 12 as our answer. Notice you get 1 mark here for getting either the 27 or the minus 12, as long as you get one of them. And now we're on to this question. I talk about this in my trigger word video that I released last week. So as soon as I see this is the magnitude of a vector, sometimes known as the modulus outside of vectors. And as soon as I see magnitude, I am thinking Pythagoras. So magnitude, or this symbol, is my trigger word or trigger notation, and I know to do Pythagoras. So I take my vector here, so v, and I'm going to do Pythagoras on it. So the square root of minus 12 all squared plus 5 squared. It's always the same. Every time you see a magnitude of a vector, you can go straight to this calculation. Now notice when we do this, brackets are really important here, because when we do minus 12 all squared, remember that's the same as minus 12 times minus 12, which is positive 144. So be careful. And then 5 squared is 25. Again, if we add those together, we get the square root of 169. And this is where, I think I said in one of my videos here, knowing your square numbers up to 15 is very, very important. So I know, for example, that 12 squared is 144. I also know 13 squared is equal to 169. That means then that the square root of 169 is equal to 13. This is what they mean by knowing your squares and cube numbers for exactly this kind of question. So the square root of 169 then is equal to 13. And for a non-calculator paper, they have to make the numbers nice so it works. If you're getting something that's kind of strange, like the square root of 110, you know something's gone wrong, go back and check your working. So those are the 2 marks at each of those questions, 27 minus 12 and 13. Right, on to question 8 here. So we have a semicircle with diameter 9 centimeters. Calculate the total perimeter of this semicircle. Give your answer in exact form. Okay, this phrase you're going to see a lot. For an area or perimeter question, what this means in real language is in terms of pi. So you're going to have to write it with a pi symbol at the end. Now, first of all, we need to know the circumference of a circle. So if I have the whole circle here, I've got my radius here, then the circumference, so the distance around the outside of the circle, is equal either to 2 pi r, 2 times pi times radius, or just pi times diameter. So you need to know this information. My cheat sheet is very helpful, so you know which formulae that you need to know. So we have a semicircle here, so half a circle. So to work out the arc length here, so this red line or red curve that I'm just putting in here. So to work out the arc, we do pi times diameter, so the full circle, so pi times 9. But we have a semicircle, so we need to divide that by 2. So that gives us then 9 pi over 2. Don't feel you need to simplify this anymore. If you write 4.5 pi, that is also fine as well. However, this is not the final answer because we're looking for the perimeter. So we want to go all the way around the shape. So we also need to include the 9 here, this diameter as well. So for the perimeter, we take our answer, 9 pi over 2, and then we just add on 9. So our answer here, 9 pi over 2 plus 9. Again, you could do some factorizing here. Notice they've written 9 plus 4.5 pi. Again, notice that is perfectly fine. Equivalent 9 pi over 2 is the same thing as 4.5 pi. You will not lose a mark for that. Notice you get 2 marks for writing 9 pi over 2, and you get the 3rd mark for adding in that 9 too. Notice you can write these both ways round. Addition works both ways round. Okay, I've had a haircut and a shave, so let's continue. So in a sequence here, we have it in slightly different notation here. So T1, so the first term is 17, then 12, 7 and 2. In previous iterations of the 0580 course, they've often just written the sequence as 17, 12, 7, 2, and then do the same things that we're going to do here. So to work out the 5th term in the sequence, remember we're going down by 5, 17 minus 5 is 12, 12 minus 5 is 7, 7 minus 5 is equal to 2. So we want to minus 5 again here. So we're at 2. We want to get to down minus 5. And how do we get there? So 2 minus 5. So 2, 1, minus 0, minus 1, minus 2, minus 3. So just making sure we go down in the same sequence, then we get to negative 3. Now this Tn here is a little bit strange. This basically just means the nth term. So if you've seen some of my sequences videos, I've gone through this a lot. So if you've got 17, 12, 7, 2, and then minus 3, going down in 5s like we've said before. So our nth term here, our Tn, will be minus 5n, so it's an nth term, so we need the n here as well. And then what do we do to minus 5 to get to the first term of 17? So we start at minus 5, we want to get to 17. What do we add here to achieve that? And we add here 22. Notice 22 minus 5, that's going to be equal to 17. So our answer here will be minus 5n plus 22, which you can also write the other way round. So 22 minus 5n. So there you go, you can see the answers. Notice it's OE, I think I've talked about this before, or equivalent. So if I wrote it the other way round, that still gets me all 2 marks for that question. Okay, on to the next one. This was very common anyway on iGCSE 0580 before in the past, when they said use without a calculator. Obviously, we have no calculator now, so we have to do it this way, and we want to add these fractions together. So our first step here is to make both an improper fraction. So we have 3 times 2 is 6, 6 plus 2 is 8, that gives us the top number, and we keep the 3 as it is. We do the same process here, so 3 times 2 is equal to 6, add on the 1, that's 7, and that converts now both fractions into improper form. Then we want to find a common denominator. Now the easiest way to do that here is just do 3 times 2, which is equal to 6. So I'm going to write both fractions out of 6. So what do I do to 3 to get to 6? I times by 2. So I now do the same to the top. So 8 times 2 is 16. What do I do to 2 to get to 6? Well, that's times by 3. So 7 times 3, that's equal to 21. Now we have the denominators the same here. We can just add the tops. So 21 plus 16 is 37 over 6. And now we convert back to a mixed number. And again, in its simplest form, by doing it this way, we avoid the whole simplest form issues. So how many 6's go into 37? Again, notice your 6 times table. And if we write out a bit of it, we notice go 1, 2, 3, 4, 5, 6 times. So that's a big 6 here. And what are we left with? Well, if we find the remainder, so 37 minus 36, that's just equal to 1. So that gives us then 6 and 1 over 6. Remember, the denominator here stays the same. And we end up with 6 and 1 over 6 for our 3 marks. Again, very important here. Again, you've got the CAO. You may not be aware of this on the mark scheme. This means correct answer only, which in normal languages, if you had 6 and let's say 2/12, for example, this would not give you all 3 marks. You have to get exactly 6 and 1/6. Okay, on to question 11 and 12. So we have some indices work here. We need to find the value of 64 to the power of 2/3. Now, the way that we do this is we split up the index here. So we do 64 to the power of 1/3, and then we do the squaring afterwards. So this is the standard method that we do here. Remember, if you've got any kind of fraction, it's some kind of root. And because we've got a 3 in the bottom, it's going to be the cube root of 64. Now, how do you find a cube root? Often students find this difficult in non-calculator. Well, basically, we're looking for 3 numbers that are the same, that multiply together to give us 64. So that's what the question's asking for here. Now, there will usually be whole numbers. They can't ask you like 0.45 or something. So what number multiplied by itself 3 times gives us 64? Well, if we try like 3, for example, 3 times 3 is 9, times 3 is 27. That's going to be too small. If we try the next biggest number, which is 4, 4 times 4 is 16. 16 times 4 is 64. Perfect. That means then the cube root of 64, working backwards, is equal to 4. Now don't forget, we're going to square whatever answer that we get. And remember, squaring is the same as 4 times 4, and that then gives us 16. 2 marks you really don't want to lose is in the middle of the paper. This will get you those B grades and possibly A grades as well, getting that correct. So be very careful. Okay, on to question 12. So work out giving your answer in standard form. Again, non-calculator skill as well. So the first thing here, we're multiplying. If we multiply, then we just multiply the numbers together. So 7.1 times 2. And then we're going to multiply the indices. So 10 to the power of minus 15 times 10 to the power of 3. Now 7.1 times 2, think of this as just 71 times 2. So that's going to equal 142. Notice we've got one decimal point here. So it'll be 1 in the answer. So we have 14.2. So we've got 1 here because we've got 1 here. And if we multiply these together, remember when we're multiplying with indices, we add to the indices. So we do minus 15 plus 3, and that gives us 10 to the power of minus 12. Now, a lot of students stop at this point and say, aha, I've got my answer. I've got all 2 marks. This is incorrect here because this is not in standard form. Remember, the number has to be between 1 and 10. So we're going to divide this by 10. So they essentially move the decimal point once. That gives us 1.42. And we do the opposite on the other side to balance it out. So I'm going to times by 10 to the power of 1. That means then 10 to the power of minus 12 times 10 to the power of 1. That's going to be equal to 10 to the power of minus 11. So our final answer for the 2 marks is going to be this. Notice in the mark scheme here, you'll get 1 mark for some idea of 142 or 10 to the power of minus 12, but only this gives you the full marks. Now, on to the next question here, adding with standard form. Now, a lot of teachers out there, and this is a terrible idea, is to write this out in long form, add it together, change it back. This takes far too long to do, so we want a different method that we can use instead. So the easiest way to do this is I'm going to take this one here, and I'm going to divide this by 10, and then I'm going to take this part and times it by 10. You're probably thinking, why do I even want to do this? Now I'm going to leave the other part alone for the time being. Now if I divide this by 10, then we get 0.52, and if we times this by 10, 10 to the power of 6 times 10 to the power of 1 gives us 10 to the power of 7. Now the reason I've done that is, notice we have the same power of 10, which then allows me to just add the 2 numbers together. So I do 5.2 plus 0.52. Again, we can use this kind of adding if you want to double check, but this gives us 5.72, and then the base stays the same, 10 to the power of 7. A really effective way to get 2 marks. Notice it took me virtually no time at all to do that. Remember this trick. Again, I've done a standard form video. I'll link it above if you want more practice on this kind of non-calculator skill. Okay, on to question 13 and 14 here. So find the number of sides of a regular polygon with interior angle 162 degrees. These come up quite a lot. So I pretend to draw some kind of polygon where this is 162. Remember, interior angle. That means then, if I extend this line, the exterior angle, because angles on a straight line add up to 180, that's going to be 180 minus 162. Which is equal to 18 degrees. Now, why is that useful? Because to find the number of sides, this is a nice formula to remember, I just take 360 and divide by that exterior angle, which in this case is 18. Okay, here we can do some cancellation. How many 18s go into 18? 1. How many 18s go into 36? That's going to be 2. And therefore we end up with a 20-sided shape that has that particular interior angle. Again, I'm showing you lots of nice little tricks here, not just going through the questions, but also where you can pick up some speed and give yourself more time for other questions. Notice the mark scheme is not particularly helpful here, just gives you this big formula, which I don't think is particularly useful. Okay, question 14 here. So we've got the range, the mode, the median, and mean of 5 positive integers are all equal to 10. Find one possible set of these 5 integers. Okay, So we've got, let's just put down some 5 numbers, A, B, C, D, and E. Okay, so therefore the median has to be equal to 10, so that's the middle number. So we know that has to be 10. Okay, that's useful, so we start off there. The mode also has to be equal to 10, so we need another 10 in there. Could be like more than one, but let's just put another 10 in here. Okay, so that guarantees, as long as I have smaller numbers here and bigger numbers here, that's fine. Okay, the range needs to be, so we've used mode, we've used median, sorry. So we've got range and mean to work with here. Okay, so if I take then E as, say, 14, I'm just making this up here, say this is 14. To get the proper range here, I have to make this 4, so that the range of the numbers is equal to 10. And now we want the mean also equal to 10. Okay, and it's integers, so we have to be a little bit careful here. So if we work out the mean here, if we add up all the numbers, so 10 plus 10 plus 14 plus 4 plus b, all divided by 5 is equal to 10. So if we add the tops here, so we have 20, 34, 38 plus b over 5 is equal to 10. Therefore, 38 plus b is equal to 50. So then b has to be equal to 12. Okay, so then my final number there would be 12. Okay, is that an issue here? So if this is 12, well, if I put it over here instead, and I have 4, 10, 10, 12, 14. Let's double check that that works. So median is 10, that's good. Mode is also 10, good. The mean is equal to 50. So 26, 30, 40, 50 divided by 5 is 50. Okay, that's all good. And the range is there. So, okay, I'm happy with that. 4, 10, 10. Interesting to see what the mark scheme comes up with here. Aha, there we are, there we are. It's the very first one up there, but you can see there's 3 different answers here. Again, notice the way I approach this question. Sometimes you get these kind of unfamiliar questions here. I started with what had to be true, which is the median. So it has to be in the middle. Then I did the mode, because it has to be at least 2 10s. It could be 3, of course. Then I looked at the range, making sure the number at the start and the bottom, again, it could have been 13 and 3 or something like this instead. I'm working with even numbers generally because I want this to come out as an integer. That's why I picked 4 and 14 or 6 and 16, something like that. And then I used the idea of the mean to work out the final number. Okay, on to question 15 here. So we need to describe fully the single transformation, so only in one go, that goes from triangle T here, so going from T then to A. Now, the first thing to notice, there is a rotation going on here. So we can pop that in, rotation. And we've got a 90-degree turn. And we're going clockwise. So this is usually the easy part to get for those 2 marks, rotation 90 degrees clockwise. What's much trickier is to find the center of rotation, so where we're rotating around. Now, tracing paper is a much easier way of doing this, but notice we can actually find this out fairly straightforwardly. If we find the same point on both shapes, we want to see where they meet at a right angle. So notice that the 2 points meet at a right angle here. In fact, if we take these points, more difficult to spot, but they also meet at a right angle at this point here as well. So there's a bit of trial and error involved, but we can actually find the center of rotation here, which is going to be equal to 4, 3 to give us our 3rd mark. Again, tracing paper is much easier. I'll link a video above which shows you a really easy way of doing this. So rotation, 90 degrees clockwise, and 4, 3. On to question 16 here. So a student measures the height of each 400 plants. That's useful. And we've got a cumulative frequency diagram to show the results. So even though it's a non-calculator paper, this is the kind of stats question they could ask you where you don't have to really use your calculator. And we want to use the diagram to find an estimate for the median. So remember, we've got 400 plants, so we need to go to half of that, which is 200. And then this is where my eyes get very, very dizzy. We read off and read down. This is much easier to do on a piece of paper, but I made the number very nice here, and that's going to be 30. Now the interquartile range here, so in order to do that, we need to find the lower quartile. So that's 25% of the data. And then upper quartile, which is 75%. And then we find the interquartile range, IQR for the cool kids, which is equal to upper quartile minus lower quartile. So let's do this a bit color-coded. Let's use green this time. So if we want 25% of the data, so 25% of 400, that's 100. So we go to 100, we read across, and we read downwards. Again, we'll try and do this as accurate as possible. So we may disagree with the mark scheme slightly. Ooh, what I'm going to say here. So 2, 4, 6. I'm going to go with 17 here. Again, this may not be completely accurate, but I'll do my best. And then we go across at 300. This is going to make me even more dizzy. And then we go downwards. I think we're halfway in between this block. Be my best guess here. And I'm going to say it's 32, 34, 30. I'm going to say it's 37. So the interquartile range here will be upper quartile minus lower quartile. That's 37 minus 17, and that gives me 20. Okay, so let me have a quick look. I'm curious. Oh, look at that, exactly 20. That is amazing. I love it when that happens. So the 80th percentile, okay, so that's a little bit different. We need to find 80% of 400. Easiest way to do this is find 10%, which is 40, and then times it by 8, so that gives us 320. So we do the same thing. This time we're going to go across in black. Across we go. Oh, that's going to be tricky to read off. Okay, let's see how we go. I think it's this line here. Get up my eyes. You can see a big part of my forehead. Oh, is that 40 or 39? I think it's probably 39. I think it's a little bit before. So I'm going to go with 39 here. Let's see how good I've done here. Yes, 39. Nice. And now the number of plants with height greater than 60 centimeters. So this works the other way around. Let's do this in blue. So we find 60 centimeters. We go upwards. This could be trickier for my eyes here. I'm not blind, not completely. There we are. Okay, and then we come across. I think it's a little bit more than 360. What's our scale here? So 70, 80, 90. Okay. 365 maybe? I'm going to put. However, this is not our answer because we want greater than 60 centimeters. So if I take my answer, 400 minus 365. That gives us 35. Are we going to be within the range? Yes, we are. Perfect. Okay, I'll go with 35 here. Again, they give you a little bit of leeway going this way around, but obviously for the median, it was quite clear cut. It was going to be 30 here. Super. Okay, and the heights are also shown in this frequency table. Okay, so it's been converted into that. And now we need a histogram. Again, still important on the 0580 course. Box and whisker might have gone, but histograms are still here to stay. Now notice, a clue for this is frequency density. They give you this in the scale. So before we actually do anything here, I'm going to create an extra row and have frequency density. And the formula for this, to work out frequency density, is frequency divided by class width. So you're probably wondering why it's up at 6 here. The reason for that is they've done 120 divided by 20. Notice it's got a width of 20 here, width of 10 here, 10 and 40. So they've done 120 divided by 20, and that's equal to 6. That's where that magical 6 comes from. 80 divided by 10, that's equal to 8. 124 divided by 10 is equal to 12.4. And 76 divided by 40, to make sure you know your non-calculator stuff here. Again, we can just simplify this down. 4 goes into both, so that's 10. Again, if you can't see this straight away, you can always just do some division. So 4s into 7 go 3, remainder 1, so 34. Okay, so it gives you 3.4. Okay, super. So now we know this, and we just have to be very careful how we plot this. So we're going from 20 to 30, so we're going to here, and we want to go up as far as 8, so we want here. This is where my eyes will definitely go crazy if it didn't for the cumulative frequency question. It is for this one, so we don't have to shade this in, but hey, it's not a geography exam, but you can enjoy bits and pieces as you go through this. Then we go 30 to 40, so going up as far as 12.4. What's our scale here? I think it is 0.4, yeah, 0.4, 0.8, 13. Yeah, it is, so that makes things a bit easier. So we want to go as far as here. Again, this is just about being patient here in your drawing. Obviously, you have a ruler in your exam. That's what I talk to all my students about. Make sure you've got your ruler. So we shade this in. This is the part of the video where people are going to skip over. I already know this. And then we go 40 to 80. So this is at 3.4. So 2.4, 2.8, 3.2, 3.4. That's in between. So it's going to go all the way across to the end and down. And then just shade it in. If you're liking this video, by the way, please do like. It really helps. Spread these videos. Again, it's great to get that feeling of like getting 10,000 views or 50,000 views on this kind of material. Okay, so there we are, and you've got the appropriate heights, 8, 12.4, and 1.9. I'm a bit confused why it's 1.9 for the last one. So let's have a look. So 8, 12.4, I'm okay with this. And then we've got 76 and divided by 40. 76 divided by 40. Just noticed it here. So again, this is the key thing. To make sure you go over your mistakes. So 4s and the 7 go 1. Remainder 3. And that's a 9. Yeah, there we are. So 19. So 1.9. Now I'm leaving this in the video. I think it's kind of useful to actually leave this in. One, because we do make mistakes. I think that's quite important to actually realize here. And it gets you challenging it as well. So if you see me doing something in the video and you go, oh, I'm not so sure that he's done it correctly, you should be challenging it. You shouldn't just be watching the video kind of idly. So this is why I leave these kind of parts in. I'm not going to get comments for this, but it's fine. So we get 1.9 there. Again, making sure you're doing the non-calculator division correctly. Okay, 17, so on to some circle theorems. Okay, this looks like a very typical question. We have a cyclic quad that even tell you that. That's quite nice. ABCD, BD, AC intersect at this X. And this is 74, BCA is 34. Angle BDA. Now, usually they do this in such an order, it kind of helps you through it. So we're looking for this angle here. And we've got angles on the same arc here. So this angle here and this angle up the top here, they're equal because they're on the same arc. So we can say that's going to be 34 degrees up the top. And then angle BCD, so that's the one over here, BCD. And this is a cyclic quad, so again we're using that information here because we have 74 and then we've got this angle over here. So to work out BCD itself, we need to do 180 minus 74. That's going to be equal to 106 degrees. And then finally ABD, which is the one down here. This looks like a trick question, but it's just angles in a triangle. So we have 74 plus 34, that's equal to 108. 180 minus 108 is equal to 72. So we get 72 degrees. So 34, 106, and 72. Perfect. In the diagram, triangle ADX is similar. Yep, very normal. Again, circle theorems and similarity often go together here. ADX, so let's identify this in the color. Let's use blue here. So ADX, this triangle here, is similar to BCX. Okay, let's get the green out here. BC, the little one over here. Okay, this makes sense because these angles are the same, and then the vertically opposite angles are also the same. BC 4.5, so let's just write in some of these things. So 4.5 centimeters. AD is 9. and Cx is 3.3. Okay, and we need to find xd, this one here. Okay, so if we look at the triangles that we have here, our scale factor, again, all has to be non-calculator. We've got the 4.5 and the 9. So to work out our scale factor, we just do 9 divided by 4.5, which is equal to 2. And we're looking for xd. Okay, so all we do here is we've already got this side 3.3, want to find this side, which is the same on both shapes. So then we just take 3.3 times it by 2, the scale factor, that gives you 6.6. Which I think I already showed you already. Yep, 6.6. Notice they often do it in the ratio kind of format. I generally have always taught it as scale factor, and then you just multiply or divide by that scale factor. Super. Okay, on to functions. Question 18 here. So we've got 3 functions to work with. First of all, we want to work f of minus 3. So wherever I see an x in here, I'm going to put a minus 3. So 3 minus 2 brackets minus 3. So 2 minuses times together, minus 2 times minus 3 gives you positive 6, and 3 plus 6 is equal to 9. And now we're doing this composite function. So remember, the f of minus 3 is equal to 9. So wherever I see that, I'm just going to replace it with the 9. So I'm actually now just working out g of 9. So wherever I see a 9 in x here, I'm going to put a 9. So 2 times 9 plus 3, that gives us 18 plus 3 is equal to 21. Perfect. And now we want to find the inverse function of f. So again, standard process, we make y equal to the right hand side, so 3 minus 2x. We switch over the x's and y's, so x is equal to 3 is 2y. And now we want to make y the subject. Easiest way to do this, we're going to add 2y on both sides. It gives us 2y plus x is equal to 3. Then I'm going to minus x on both sides. That gives us 2y is equal to 3 minus x. And then finally, to get y on its own, I'm going to divide by 2. That gives me then 3 minus x over 2, which I'm going to pop in over here. Again, you could also write this as like a half bracket 3 minus x as an alternative here. If we look at the answers, they've written it the same way I have, but again, you can also write it differently too. Perfect. Right, question C. Find x when g of x is equal to 7. So g of x is 2x plus 3. So to work out g of x, which is kind of confusing, wherever I see an x, I'm going to replace it with its own function. So what that means is, I write the 2. Wherever I see an x, I'm going to put a 2x plus 3. And don't forget, I already have a plus 3 here as well. Kind of a bit confusing. Now we multiply out the brackets. So 2 times 2x is 4x. 3 times 2 is 6. Then we add the 3. That gives us 4x plus 9. And now we need to solve this very straightforward equation. So we take our answer 4x plus 9, make it equal to the 7. And then I'm going to minus 9 from both sides. Gives me minus 2. And then x is equal to minus 2/4, which you should simplify here to minus a half. Perfect. Okay, so let's take the equation here. So h inverse x is equal to 5. What I'm going to do on both sides is do h on both sides. Now, if I do h on both sides here, so I'm going to add an h to both sides. Notice that h and h inverse, they cancel. They're the opposite operations, like timesing and dividing. And we're left with just x, but we still get the h of 5 on the right-hand side. Now, h of 5 here, if our function h of x is equal to 2 to the power of x, h of 5 will just be 2 to the power of 5. And 2 to the power of 5, again, you should know your indices really well at this point, is 2 times 2 times 2 times 2 times 2, and that gives us 32, which gives us our 2 marks here. Right, so you can go through the answers and check that you're happy with all the working here. On to question 19, some surds. We knew this was going to come up at some point. So first of all, we're going to simplify our surds here. The easiest way to do this is look for the biggest square numbers that fit in. So with the square root of 32, notice this is the same as 16 times 2. I'm using this because 16 is a square number. And the same thing here, I can also do 49 times 2 to represent 98. Remember, 49 is also a square number. Now, the reason we've done that is we're going to split it now. So we're going to get the square root of 16 times the square root of 2, and then the square root of 49 times the square root of 2. Now, we know what the square root of 16 is. That's equal to 4. And we know what the square root of 49 is. That's equal to 7. And notice, if it's like 4a plus 7a, that's equal to 11a. We do this in the same way. So 4 lots of root 2 plus 7 lots of root 2 is just 11 root 2 for our 2 marks. Now, rationalizing denominator, particularly this kind of trickier question, we want to multiply by its conjugate. What does that actually mean? Well, we multiply by its negative in this case. So root 2 minus 1, top and bottom. Now let's see why we're doing this in the first place. Now 1 times anything is just itself, so we leave this as root 2 minus 1. The reason we've multiplied it by this, and remember, multiplying the same thing top and bottom doesn't change what it is. Root 2 times root 2 is just 2. And then we have minus 1 times root 2, that's equal to minus root 2. Root 1 times root 2 is plus root 2. 1 times minus 1 is just minus 1. And the whole point of this process is the horrible surd stuff cancels, and then we get root 2 minus 1 over 2 minus 1, which is then just root 2 minus 1 to give us our 2 marks. Again, you can have a look through the answers, not much there in terms of helping you understand what's going on. Okay, on to question 20. So some variation and proportion. So y is proportional to 1 over root x, and we need to find this value of y. So first of all, we take our proportionality statement, make it an equation. So we get y equals k over root x. Now, step 2 is to work out what k is by using these values. So when y is 8, so I'm going to put 8 for y, and then for x, I'm going to put a 4, so root 4. Then that gives us 8 equals k over 2. Remember, the root of 4 is equal to 2. I'm going to multiply by 2 on both sides. That gives me here 8 times 2 is 16. This cancels, giving us just k, which is really important. We need this for the next step. So step 3 here, we're going to write out our equation now that we actually know what k is. So 16 over root x, and then find y when x is 49. So when x is 49, then y is equal to 16 over the square root of 49. Remember, the square root of 49 is 7. And we'll probably leave our answer here as 16 over 7, or we can write it as a mixed number. Notice both are absolutely fine here on our mark scheme. Okay, and on to question 21. So we've got 2 shapes here, a triangle and a rectangle, and we're given the heights here of the rectangle and the triangle in terms of h, and the base in terms of x. The area of this triangle is equal to 11 square centimeters. This is equal to 39 square centimeters. And we want to find an expression in terms of x for the height of the rectangle. Okay, so this height here, the h plus 2. Well, notice if we actually multiply the two things together, that gives us the area. So that means that h plus 2 times x plus 1 is equal to 39. And again, we just want to get this part on its own, the height of the rectangle, so we can divide by x plus 1 on both sides. And that gives us then h plus 2 is equal to 39 over x plus 1. So again, 1 mark question, it shouldn't be anything too complicated to get there. The second part, however, is a bit more complicated because somehow we need to find this quadratic here. Now, generally we haven't used the information for the triangle yet, so this will be my next focus. And notice the formula for the area of a triangle, so area of a triangle, which we know is equal to 11, is equal to a half base times height, so a half x times h. And that's something that we can work with here. Certainly we can times both sides by 2. 11 times 2 giving us 22. This cancels, and this gives us then xh. And actually we can get h on its own here by dividing by x on both sides. That gives us 22 over x is equal to h. So notice we've got this formula here. We've also got from the previous part of the question that h plus 2 is equal to 39 over x plus 1. So we can combine these things together. So if we want to combine this together, we can replace our h in here with 22 over x. So we get 22 over x plus 2 is equal to 39 over x plus 1. Okay, this is kind of an ugly equation at this point, but we can certainly do some things to make this tidy. The first thing I'm going to do here is I'm going to multiply all sides of this equation by x and x plus 1. Let's see what happens. So if I multiply by x, this cancels, but I'm still multiplying by x plus 1, so this gives me 22x plus 1. The 2 I'm multiplying by this directly, so 2x brackets x plus 1. And if I multiply this part by x plus 1, this part cancels, but I'm still left with the x, so 39x. Now we've got into something that we can work with. We can expand some brackets, so we get 22x plus 22 plus 2x squared plus 2x is equal to 39x. Let's bring everything to the left-hand side. So that gives us then 2x squared. We have, at the moment, plus 24x. We've got a plus 22, and we've got 39x. So all we need to do is minus 39x on both sides. That gives us then 2x squared, which is all good. 24x minus 39x is minus 15x. That's looking very good. And then plus 22 is equal to 0. It's one of those lovely questions where you know you've got the right answer and got all 3 marks on that. Now, once you have this quadratic, they want you to factorize and then solve to find the 2 possible heights of the triangle. So this is a more difficult one to actually go and factorize. Now, I like this kind of quick way of doing it rather than splitting the term, which you can also do, of course, as well. I know to start with I need 2x and x in my brackets. And 22, there's not many factors. Yeah, you've got 1 and 22, and you've got 2 and 11, and that's it. So my first thought is using 2 and 11, because generally this number is less than 22, so I'm going to go with the numbers that are slightly closer to each other. And with a little bit of thought here, we can go, if I put a minus 11 here and a minus 2 here, that gives me a positive 22. And if I check my FOIL this way round, I do get minus 15x. A nice quick way of doing these questions, which will save you a ton of time. Now it means then either x minus 2 is 0, which means x is 2, or 2x minus 11 is 0, 2x is 11, so x is equal to 5.5 or 11 over 2. Now this is not the answer because we want h, but remember our formula from before, h is equal to 22 over x, so we can put x into this twice. So that means either h is equal to 22 over 2, which is 11, so that's our first answer, or h is equal to 22 over 5.5. It doesn't look very nice, but we can times top and bottom by 2, giving us 44 over 11, and that's equal to 4. Again, the numbers should be nice. Remember, this is a non-calculator paper. Perfect. And so we get to our final answers here of 4 and 11. Okay, on to question 22. So we want to find the exact value, very important, of x. Okay, so I'm going to be using trigonometry here. I'm going to label my sides. So I have the adjacent and the hypotenuse. So I'm going to be using cos. So again, you can use formula triangles or the formula of cos is equal to a over h, whichever you prefer. That means then that cos of 30, so our angle, is equal to a, which is 8 divided by x. Now we can rearrange this slightly by timesing by x on both sides. That gives us then x cos 30 degrees is equal to 8, and therefore x is equal to 8 divided by cos 30. However, you need to know your exact values of cos 30, and cos 30, which is the same as sine 60, so you can use kind of tricks to remember this, is equal to root 3 over 2. Now, if you're not aware of how I even got that, then do check out the video above where I go through those exact values. So I can just pop this in, 8 over root 3 divided by 2. Again, this is not the most tidy fraction that I've got in the world. Again, you can think of this as divided by root 3 over 2. And this is the same as 8 times 2 over root 3. And that gives me then 16 over root 3. I'll be interested to see whether you can leave it like this, but generally you'd be expected to rationalize, so times top and bottom by root 3, and then that gives me then 16 root 3 over 3. So let's see how strict they are, but probably they're expecting 16 root 3 over 3. Let's see if they lose a mark here. Nope, they're perfectly happy with both, so that's quite nice to have. So this gives you all 4 marks. On to question 23, so write as a single fraction in its simplest form. So I'm going to do some cross multiplying to get our common denominator. So to get our common denominator, we're just going to put the 2 brackets together. And then to work out the numerator, we do this times this, this times this. So we get 3 brackets x plus 3 minus 4 brackets x minus 4. Then we do some expansion, so we get 3x plus 9 minus 4x plus 16. Be very careful. 2 minuses making that plus. Leaving the bottom factorized is perfectly fine. Done a nice Udemy course that's got this in here, and that gives us then minus x plus 25 over x minus 4, x plus 3. So we can write that in. You can do 25 minus x, of course, as well. Okay, which they did in the final answer. 24. So we're now on to completing the square. So we're now writing this in this particular form. Again, easy way to do this is you take half of the middle term, so that's 2. So that gives us x minus 2 all squared. Now if you think of that expanded normally, that gives us then x squared minus 4x plus 4. But we want a plus 7, so what do I add to 4 to give me 7? Well, I add on a 3. And I've got it in the form that I am looking for. So a is here 2 and b is 3. And the reason we do this is we can work out the minimum point, or the turning point in this case. So we switch the sign here. So we put a positive 2, and then we leave the sign alone for what's outside. So we just get 2, 3. Okay, on to question 25. Again, similarity, but a much trickier question here. So we're told these shapes are mathematically similar. The area of the larger shape is 36 square centimeters. So let's pop this in. So 36 square centimeters. And the area of the smaller shape is 25 square centimeters. Perfect. The height of the larger shape is 9 centimeters, and the height of the smaller shape is x. And we need to find x. Now notice we have the area scale factor, which is really important to realize, which is simply 36 divided by 25. However, we want the length scale factor because we're trying to find a length here. And so we need to find the square root of 36 over 25. Now notice these are nice numbers, which will always be on a non-calculator paper. So the square root of 36 is equal to 6. The square root of 25 is equal to 5. Now we've got that scale factor that we can work with. Again, then we just need to work out what x is going to be. So x here, all we're going to do then, we're going to take the 9, and because we're going from bigger to smaller, we're going to divide by 6 over 5, which is the same as multiplying by 5 over 6. There should be some cancellation here to help us. So notice 3 goes into 6 twice, into here 3 times. This gives us then 15 over 2, which is equal to 7.5. So notice we're getting nice-ish numbers to work with, and of course x needs to be smaller than 9. So they give it as a fraction, 15 over 2, again 7.5 is equivalent, so it's the same thing. Okay, and on to the last question here, so question 26. So we have our function, x brackets x plus 2, x minus 3, and we need to sketch this function. First thing to notice is we have a cubic function, so we notice we're going to have an x cubed if we multiply this out, and generally it has a shape that looks like this, or at least a positive cubic, where it has 1, 2, 3 places where it crosses the x-axis. And we can actually work out where those are by taking our equation and setting it to 0. If this is true, then either x must be 0, either x plus 2 is 0, which means x is minus 2, or we can have x minus 3 is 0, which means x is equal to 3. So these are the places that it crosses the x-axis. So we can put those in. So we have 0 here, we have a minus 2 here, we have a positive 3 over here. And so we can then just draw in our cubic going through here, 0, and then finally going through here. Again, notice going to infinity in both directions, but it only wants it between -3 and 4. So if you look at the mark scheme here, again, you get essentially the correct sketch without labels, and then B1 for any positive cubic should be going through -2, 0, and 3, and should be indicated on the x-axis. Okay, and now we just need to expand and simplify this particular cubic. So the easiest way to do this is we're going to take the first bit and just expand that. So that gives us then x squared plus 2x. And then we have x minus 3. And now we can use FOIL to expand here. So first outside, inside, last. So x squared times x is x cubed. X squared times minus 3 is minus 3x squared. Plus 2x times x is plus 2x squared. And then we have 2x times minus 3 is minus 6x. And we can simplify this down then to x cubed. We've got minus 3x squared plus 2x squared is minus x squared, and then minus 6x. Notice there is no y-intercept because there is no number in this expression. Then A is the point 1 minus 6, tangent to the graph at that meets the y-axis at B. Find the coordinates of B. So there's a lot of information here. So first of all, we've got our expression, so we're going to use what we've just done. So we have f of x is equal to x cubed minus x squared minus 6x. And as soon as you see tangent to the graph, you need to be thinking differentiating. So we want to find the gradient function of this. The way that we do that is we take the 3, we bring it to the front, so we get 3x. And now we reduce that by 1, so that's squared. Do the same here, bring it to the front, which is minus 2x. Reduce the index by 1, so it just gives us 2x. And then here, if you find the gradient of a linear function, you just take the number, so minus 6. Okay, so tangent of the graph of y equals f of x at A meets the y-axis at B. So first of all, we've got the point 1 minus 6. We want to find the gradient at that point. So we want to find f dash of 1. So wherever I see an x, I put a 1. So 3 lots of 1 squared minus 2 lots of 1 minus 6. That gives us 3 minus 2 minus 6, and that gives us minus 5. So that means then that this tangent line has the equation of y equals minus 5x plus c, because this is what the minus 5 gives us. It gives us the gradient of the tangent line. Now to work out the y-intercept, we can then just put in this number or this coordinate. So when x is 1, y is minus 6. That gives us minus 6 equals minus 5 plus c. That gives us c then as minus 1. So we have our tangent line, but we want to find where it crosses the y-axis, and notice we've kind of done that already for free because we've got this minus 1 here. So we're going to cross through here at 0, minus 1. And you can see all the different working that's required to get that 5 marks, although once you understand this kind of question, it's not actually that tricky a question to do right at the end of the paper. Okay, and if you're looking for predictions about what's going to come up on May 2025 exams, then do check out the video right in front of you, because that's going to help you a ton to get ready for those exams that are coming up very, very soon.